Well, we're going to go ahead and talk about solving logarithmic and exponential functions here. And then we're going to look at doing calculus with exponential and logarithmic functions that are not base E. Well, to begin with, when we're not dealing with base E, like a number raised to x, then we would need to go ahead and use our kind of change of exponent and base formula, and we would go e raised to the ln of a times x. Now, remember when you have e and then you have ln in the exponent, they cancel each other out. So this e to the ln of a is really just that a, still raised to the power of x like we have over here. That's going to come into play here in a little bit here, if I can talk. Okay, we have half-life, carbon 14. We have all this stuff here. We have our formula then. Now, since we're starting out with 1 gram, we're going to have 1 in front. When we have half-life, that means how long it takes for half of it to remain. And now our exponent's the number of half-lives. Well, to figure out the number of half-lives, you take the total number of years and divide it by how long it is for one half-life. That's what our exponent ends up being. We want to know, well, what happens after 10,000 years? So we put 10,000 in for t. And then basically all we have to do is just put that in our calculator, because not many of us can do that in our head. And we get about 3/10 of 1 gram. We started out with 1/10. After 10,000 years, there'd be about 3/10 of a gram left. Now, in the last slide, we talked about, well, what do you do when you have a number raised to a variable that's not e? And we said, well, you got to use this formula here to change it. Well, if you're dealing with a base that's not base e, we would want to change it to base e by using our change of base formula. Basically, we want to take the log base a of x and go 1 over the natural log of a, all multiplied by the natural log of x. So x refers to whatever's after your log, and this is our base right here. Also, remembering your definition of a logarithm right here, going from the logarithmic form to the exponential form. Also, just as a reminder, base b right here and here have to be positive and not 1. And then x has to be positive. So remember, whatever's after your log has to be positive. And then just to refresh your memory on properties of logarithms, that log base a of 1 is 0, because this means a to what power is 1, and well, that's 0. And then remember, the log of two things multiplied together is really the log of the first one plus the log of the second one. Or if you have an exponent on the variable after your log, you can put that exponent down in front. You can only do this when that exponent's on the variable after the log. Or on this one here, when you have the log of two things divided, well, you go log of the top minus log of the bottom. And here, your log base a of a, they cancel out, leaving you with the x. Same idea here, your a raised to the power of log base a of x. The logs and the base a's cancel out, leaving you with x. So now we want to go ahead and just solve something like this. This is an exponential equation because our exponents are variable. So there's a couple ways you could do it. You could take the natural log of both sides, or you could take the common log of both sides. If you do the common log, that's really log base 10, which isn't written. Now we have an exponent after our logarithm, so we can put that down in front. Now we have x multiplied by numbers, so all we have to do to get x by itself is divide. And there we got x by itself. That's our answer. Over here on the right side, we already have a logarithmic equation trying to get x, so we got to undo the log, so we got to take our base of 2 and Tarzan it over, going from the logarithmic form to the exponential form that was on the previous page here. So take our 2, swing it over, it hits the 4 up as the exponent, and so we get x equals 2 to the negative 4. Remember, the negative exponent puts it down in the denominator, so we get 1 over 2 to the 4th, or 1/16.